Hi, this is Mrs. Sigmund. The first lesson for this week is going to be from section 2.3 on solving multi-step equations. We're still in unit 1, so the date might be the same, it might be different depending on which day you're starting to look at this. Okay, so multi-step equations are just like our one-step equations, except that instead of only adding, subtracting, multiplying, or dividing, we might have to do more than one of those to get x totally by itself. So our first step again is going to be looking for the variable. I see that x is on the left side, so I need to move everything else away. We're going to start with that plus 12. We need to do those opposite operations. We have a plus 12, so we are going to subtract 12 from both sides. Notice I do that on each side of the equation. So if you need to, you can draw a line from your equal sign down. That way you see a minus 12 just happening once on each side. Okay, those 12s will cancel out, and over here on the left, we're left with 5x. And then on the right, we want to be careful with negatives, but this is going to be a negative 25. 5x is really 5 times x, so if we divide by 5, we'll be left with just x equals, again, be careful with those negatives, of negative 5. And that will be our answer. Okay, we're going to look at a few examples of these. So this one, I see a set of parentheses, and that jumps out to me as needing to be distributed. So I'm going to take the 16 and I'm going to distribute that. 16 times 1/2 x gives us 8x. And then 16 times the negative 1 is just a negative 16. Once you distribute, you don't need the parentheses anymore. And then I keep that equals 39. My x is on the left, so I need to move my 16. I'm going to do opposite operations again. So we're going to add 16 to both sides. They go away on the left, and we're left with 8x. And on the right, we have 55. 8x is really 8 times x, so we will divide by 8. And that gives us, I'm going to write over here, x equals 6 point, that didn't show up, 0.875. And you can use a calculator to do that. That wouldn't be something that we necessarily expect you to know off the top of your head. But decimals are reasonable answers. Don't panic when you get decimals or really large or really small numbers. They do exist, and so they will show up in our work. Okay, here we have a fraction. I can find my variable on the left side, but as far as undoing operations, that 4 is kind of blocking me from getting to the y minus 1. Again, those fraction bars are really telling us to divide. So the opposite operation here is going to be multiplication. So we're going to multiply by 4 on each side. They cancel out on the left, leaving us with only y minus 1. And then we have negative 8 on the right. We'll add 1 so that the y is by itself. We'll get y equals negative 7. Okay, here we have a fraction again. But before I deal with the 7, I can move that 3. So that's what we're going to do first. We're going to add 3 to both sides. That gives us 9. And then we still have that m over 7. And again, that fraction bar is really just showing us division. So the opposite operation tells us to multiply. So we'll multiply by 7 on both sides. 7s will go away. So we'll have the m over here on the right. And then on the left, we'll get a 63. And you can just leave your answers like that. You don't need to switch it to be m equals 63. This is good enough for us. Okay, this one looks a little bit more complicated because we have more terms. But if I look and find my equal sign, over here I have two terms that both have an M. So we're going to combine those like terms before we get started. So maybe we rewrite the equation, switch colors here, as 5 equals 7m minus 23. And we'll just combine those two pieces. My m is on the right side, so we want to move the 23 first because it's not connected to the m. So we'll add 23. That gives us a 28 equals 7m. And again, 7m is just multiplication, so we will divide by 7, leaving us with 4 equals m. The last types of examples we want to go through use this phrase consecutive integers, or in this case, we have consecutive odd integers. And so we need to think about what that means. Consecutive tells us that things happen one right after the other. So like 5, 6, 7. But if it's a consecutive odd integer, we are talking about things like 5, 7, 9. They go in order, but they're just the odd numbers. We know that for these three odd numbers, their sum is 69. Well, we already learned some things about this. We know that sum tells us that we're going to add. So we're going to have three pieces that we add together. And then that is tells me to have an equal sign. And then my 69. For numbers we don't know, we use variables. So we're going to throw an x in the equation. That's going to be the first odd number that we don't know. For consecutive odd integers, if we look over here at the example, jumping from a 5 to a 7, we skipped 2. So that middle number is going to be x plus 2. It's that first number, but 2 more. And then thinking to get to that third one, we want to jump from 5 to 9. And so that's 4x plus 4. Because we would do 2 more than the first number to get the middle, and then 2 more than that. And so that's that 2 plus 2 is giving us 4. Now, if you can kind of picture this without those orange lines, it looks more like a normal equation. And we're just going to combine like terms. So we have three pieces that have the variable. And those add up to 3x. Then I have a 2 and a 4, so that gives me 6. And now we're just simplifying this using our solving techniques. So we will subtract 6 from both sides. Get 3x equals 63. And then we will divide by 3, leaving us with x equals 21. But if you go back to your question, it wanted to know what the three integers were. We found the first one. So we'll just list out the next two. That would be 23 and 25. Okay, that one was odd integers. I just want to talk real quick about what it would look like for some other scenarios. So these two examples, I have just consecutive integers and then consecutive even integers. They're still going to have that same general structure here. But we want to think about how far apart these numbers end up being. Consecutive integers, again, just go in order. So like 1, 2, 3. They're only one apart. So we'll start with our x. But then in the middle, it's just x plus 1. Because from 1 to 2 is only skipping 1. And then the third number is x plus 2. Because again, we're just increasing by 1 each time. And then it'll tell you what to set your equation equal to. For even integers, it's going to feel really similar to our odd integers. Even integers might be 2, 4, 6. They're still 2 apart. So we're going to start with our x. And then this is still going to be x plus 2 and x plus 4. The difference will come in what they're set equal to. This one is 30. If you look back at the previous example, that odd integers was set equal to 69, an odd number. That will kind of take care of itself. When you go to solve this one, you'll end up with an even number for this first term, and then you'll be able to list your consecutive even numbers. Okay, that finishes this lesson. There's an assignment in Reveal 2.3 multi-step equations, or a PDF is also available if you prefer that method or if Reveal is still not set up for you.